Hey everybody, Mrs. Bixler here, and we are cruising through Unit 5. Woohoo! The thing we're going to talk about today is is how parallelism deals with triangles. And not really deals with it, but like how it plays into it. And you'll see parallelism is a big deal when we talk about quadrilaterals, but it's not as big of a deal with triangles, but it will come into play, which is kind of exciting. So we're going to talk a little bit about triangles. This first slide is earth-shattering. What do you know the sum of the interior angles of a triangle is? 180 degrees. Slide one, done. Amazing. Good job, everybody. The other thing I want to talk about was the no choice theorem. So we've talked about this before in class. And the no choice theorem, remember, tells us if I know that I've got these two angles that are congruent to each other in two triangles, and I know that these two angles are congruent to each other, I have no choice. And I know that these two angles have to be congruent to each other. So let's make this a little bit more concrete and obviously just run with me here. Let's say that I know that this is 100 degrees. Then if I know they're congruent to each other, this guy is also 100 degrees. And I'm making this up. Let's say that this guy is 30 degrees. And so then this angle also has to be 30 degrees. Now, if we're looking for our red angle, well, I know that they have to add up to 180, right? As I know from my first slide. So I know, no doubt, that these guys both have to be 50 degrees. So that's just simple math, right? But we can do this in a more general way because of the no choice theorem. So I've got two triangles here, and I know that this angle is congruent to this angle. I know that this angle is congruent to this angle. I have no choice. I know that this guy is going to be congruent to this guy. That is the no choice theorem. All right. Moving on. I want you to pause the video here and tell me what you know about A and B. All right, we're back. So we know that in a right triangle, all of the angles add up to 180, right? Because we know that from our first slide. Best teacher ever. But in a right triangle, I know that this guy is 90 degrees. So 90 degrees out of my 180 has already been taken care of. So what you want to look at here is then what do A and B have to add up to? A and B have to add up to 90. And so if A and B add up to 90, because we know all of our definitions, we know that A and B have to be complementary. So always, always, always in a right triangle, the two non-right angles are going to be complementary to each other. All right, I know this is a lot of info. It's coming at you fast. Now we're going to just do some nice math. So I want you to pause the video and solve for X. All right, we're back. So hopefully you figured out what X was and you looked at it like this. So you said, oh, I know that this bottom right-hand corner is going to be 64 degrees. Sorry, bottom right-hand angle is going to be 64 degrees because I know the sum of the interior angles of a triangle is 180. And then I know that 64 and X are supplementary to each other because of subpost, right? They're a linear pair. So, hopefully you got that X is 116 degrees. Great job. All right, let's do it again. Go. Solve for X. All right, we're back. I'm not going to reveal yet what X is because I wanted to show you something. And I wanted to show you how I thought about this problem. So let's look at this guy. So hopefully you figured out that this guy is, that this missing angle is 65 degrees. Great. So I know that it's 65 degrees because I know that 180 minus 80 plus 35 is 65 degrees, right? So 180 minus the sum of those two angles has to be 65 degrees. But I also know something else. I know something about the relationship between X and 65. And well, just like we said before, they're a linear pair, so they're going to be supplementary, which means they add up to 180. So let's look at this relationship now. So now I know that 180 minus 65 equals X. So pause the video right here and just make sure you understand that association. All right, we're back. So look, if I know that 180 minus 80 plus 35 equals 65, watch this. I know that 65 equals this. So I'm going to plug this in to this equation down here. So I'm going to keep this 180. And then I'm going to subtract from 180 all of this red stuff. So 180 minus 80 plus 35. And look what happens, and that equals x, right? I should switch that to purple so it stays consistent. So look what happens here. So right off the bat here, I get 180 minus 80 minus 35, but then this 180 negates it. So look what winds up happening. All of these drop out, and I wind up getting that 80 plus 35 equals x. That's a 35. I had a delay in my pen. There we go. Pause the video and make sure you understand this mathematics. All right, so hopefully the arithmetic worked out for you and you saw that that all dropped out, including this little negative guy. And so wait a second. You're telling me that I don't have to do this 180 minus 80 plus 35. I can just do this. Yes, you can, my friends. So 80 plus 35 is going to be equal to x. So hopefully you got that x equals 115 degrees. So this is an important relationship here. This is what we call the exterior angle theorem. And the exterior angle, so right now what we've been solving for is this angle x. And x in this situation is an exterior angle. An exterior angle is this. So if I have a shape, and it can be a triangle, it can be a quadrilateral, it can be a pentagon, it can literally be any polygon. If I extend one side, that's going to give me an exterior angle. So for every interior angle, there is one exterior angle. So the exterior angle is always going to be the supplement to whatever that interior angle is. So over here, I've got this exterior angle and it's the supplement to this guy. And then if I extend this side, I've got this exterior angle and it's the supplement to this guy. So an exterior angle is always going to be the supplement to the interior angle. And so that leads us to this exterior angle theorem. So in a triangle, the exterior angle, so this guy right here, is going to be the sum of the remote interior angles. And remote, that word remote, well, a lot of you know it now because you've been learning remotely. So remote means far away, or like think about a remote control, right? So you can use the remote control so you can get up to change the TV. I used to have to do that. It was devastating. So the remote interior angles mean the two angles, this one and this one, that are furthest from this exterior angle. So this angle right here is going to be the supplement of my exterior angle. So I'm not talking about this one. I'm talking about the ones that are furthest away. And this is what we lovingly refer to as the exterior angle theorem, EAT, EAT or EAT, as one of my students once said. All right, so we are going to move on to the next and last slide of this lesson. I want you to pause the video and solve for X, Y, and Z. Okay, we're back. So hopefully you found this really easy using the EAT. So I got that X is 102, whoop, whoop. Y is 59 degrees, and Z is 54 degrees. Good job, everybody. Go tackle the homework, and I'll see you soon. Thanks.